Hello guys, hope all of you are doing great. Till now we have written a few very simple 8086 programs, and what we learned from those programs are like how we can store some data, like some numbers, say for example, in a register. And then also we have seen how we can declare variables in 8086 programming, and then how we can move data or how we can store data in those variables, and how we can move data from those variables to registers, and again from registers to those variables. Those simple things we have seen actually up to this point. And one important thing in all these programs were like we executed the program in debug mode. What exactly we do when we execute the program in debug mode is basically we see how the state of the microprocessor evolves after the execution of each instruction. When I say state of the microprocessor, it means like how the content of the registers changes and how the content of the memory changes after the execution of each and every instruction. And that's how sort of we verified like whatever the programs we were writing were more or less right. Now, the point here is this debug mode is certainly very useful when we want to understand the behavior of a program, and at the same time we want to detect or some logical errors specifically in the program. We want to correct those logical errors. So we might want to know how these instructions are changing the content of the variables as well as registers. But in general, what happens is what we want from a program is actually we want our programs to generate some output. When I say output, in the sense like generating some text on the screen, on the output device. Now, till now, whatever the programs we wrote, none of them were actually generating any output on the output device. That is, none of them were generating any string on the output device. Now, in this video, what we're going to see is like from a 8086 program, how we can display a single character. Say, for example, A, B, C, D, like that. A single character on the screen. And also we will be seeing like how we can display a string on the screen. String in the sense, say, it's a collection of characters. Now, first we'll be seeing how we can display a single character, and then we'll be seeing how we can display a string on the screen. Or we might do it in the reverse order also. Okay, that we'll know in a moment. Okay, then let's begin. So for that reason, what am I going to do is I'm going to open this Visual Studio, and there I'm going to open this TASM folder, as you already know. Once it is open, let me expand this TASM folder, and then I'll be creating a new file there, say pp5.asm. You can give any name you want. And then let's start writing the program. There will be some data segment that will fill in a moment. There will be some code segment that again will be filling in a moment. And then the stack segment starts with this 10 address. Let's write the code segment. First, what we have to do is we have to copy the base address of the data segment register to the we have to copy the base address of the data segment, not the data segment register. We have to copy the base address of the data segment to the data segment register. Okay, I'll try to give you a brief explanation of that thing in a moment. But before that, let me write it first. So what we want to do is we want to copy the base address. That how do we get it? Just by writing this @ symbol of the data segment. This is how we do that to AX register, and then from this AX register, we'll be copying it to the S register. Now, what is this base address of the data segment? Let's see here. Let me show you. You can think of the memory of to which this 8086 processor is connected with in some way. You can think it of in this way. It's a like long strip thing like this, and then this memory you can think like, okay, it is this broken into some 64 kilobytes of block, and these blocks are actually referred to by some name that we call as, say, for example, this is the code segment, this is the data segment, this is the extra segment, and then somewhere it is the stack segment. Now, these are inside these, you can think like these are like 8 bits like that. Say, for example, this 8 bits of the data segment like this. This is the first 8-bit of the data segment, second 8-bit of the data segment, third 8-bit of the data segment, like that. This is the 0th 8-bit, the first 8-bit, the second 8-bit, or the third byte, I can say in that way also, the fourth byte, the fifth byte in the data segment. Now see, in this big memory, the starting address of these code segment, this code segment, that is this 64 kilobyte, this particular number will be stored in a register, CS register. Similarly, the starting address of this 64 kilobyte, the memory will be stored, should be stored in this DS register, like that. Similarly, ES register will point to this ES segment, and stack register will point to this stack segment, okay, beginning of the stack segment. Now, when we do move AX comma at the rate of the data, it means what we're trying to do is we're trying to copy the starting address here, this particular byte number, to this AX register. And then from there, certainly when we do ds comma ax, so that way we'll first copy it to ax register, and then from here we'll be copying it back to ds register. Directly this copying is not allowed, like from this whatever this base address is, you might be thinking, why not we directly write here ds? So if you try to do that, it will show you an error. I mean, you first have to copy it to an accumulator, and then only from that accumulator you can copy it to ds. Okay, that's how the things works. Now, let's say we sort of understood this, the importance of these two lines there, and then after that, what we do is, okay, these are my first like few lines. Always you have to write it that way only, like sort of the part of the skeleton of a 8086 program. And then, also at the end, at some point of time, we have to terminate the program. And for that reason, what we do is we first move this to AH register, this 04CH, I mean H from hexadecimal, and then we have to call this int21H, and then this is the end of the program. Now, what is our goal? We want to display the display a single character on the screen, and also we want to display a string on the screen. So let's first we'll see how we can display a string on the screen. So for that reason, what we have to do is, whatever it is the string that we want to display on the screen, we have to store it in the data segment. It means, see here, whatever the program's data are there, like whatever the variables and whatever the data on which the program is going to operate upon, those data must be stored in this data segment, in this area of the memory. Okay, so if we want to display a string on the screen, that first thing that we have to do is we have to store the string in this data segment. So somewhere some byte number will be there. Say for example, see, width of this memory, I'm saying it is like 8 bits, okay, for simplicity. Now it means this is the 0th byte, first byte, second, third, fourth, fifth byte, like that. So if we have to store the string hello, then what we have to do is, say for example, we want to display hello. In that case, we'll be storing H E. See, H is a we have written H. These are ASCII codes, right? So ASCII code means each of these symbol can be associated with a 8-bit number. That will be called as the ASCII ASCII code of this particular character. Okay, but if it is not, like, I guess people certainly know this thing, but this H is nothing but it is a number actually. Okay, this H is a symbol for a particular number, 8-bit number. Similarly, this H is the symbol for another particular 8-bit number, like that, HELLO. So that way we will be storing the string somewhere in the DS segment, and at the end of the string we always have to write this dollar symbol to mark the end of the string. Why it is important? We will know, we'll come to that point in a moment, but for the time being, what you need to know is that, okay, we have to store the string along with this dollar symbol at the end. Okay, now see, when I say the string should be stored in the memory and each character will occupy 8 bits, it means what? This will be the byte number, somewhere it will start. Let's say for example byte number 100. Okay, So this is your byte number 100. So it will be byte number 101, 102, 103, 104, 105. Consecutive bytes will be allocated to the consecutive characters. It will be not like H is stored in 100, then E is stored somewhere else. Say, for example, 509. It will not be stored that way. The bytes will be consecutive, one after another. Now see this starting byte number is actually the address of the string. You know, in C programming language, so if you have a character array, say say for example s of 10 characters, right? I mean, when you write say this s, simply the name of the array, it basically represents what? The address of the first element present in the array. So basically it is the starting address of the string, or you can say it is the address of the string. Okay, that's what it is actually. It is the byte number. It is the byte number, the first byte number. I mean, what I mean is like it is the byte number of the first character in the string from where it is stored. And that is called the address of the string that we are going to use in a moment. That's why I said it. So what we learned is like what is the importance of copying this data segment register to this, I mean the starting address of DS to data segment register, and then here how we store the values in DS and what we mean by the address. Now, okay, what we did is we have stored here this string hello, and we want to display this particular string on the screen. How do we do that? So first thing, as I said, we have to store it in the data segment. So how we are going to do it? We are going to do it in this way. It's just like declaring a variable. So how do we do it? First, we have to give it a name. Say, for example, I want to call it str1, and then we have to write db because each of these character is going to occupy one byte. So for that reason, it is db. And then within double quotation, we have to write this string hello, hello. And then, as I said, we have to write this dollar symbol just to indicate that okay, that is the end of the string, and it will be used at some point of time. That's why it is important. I'll be telling you when it is used. Now str1 db hello. As soon as we write this particular line, what it will do is it will store hello somewhere in the data segment where each of these characters will occupy 8 bits, as it is shown in this particular picture. Okay, done. Now once we have the string in the memory, then what we can do is our goal is to actually display the string on the screen. So for that reason, if you want to do it, for that reason, what are the steps? The first thing is that the address of the string should be stored in the DX register. What I meant is there is this DX register there, right? You people know this is another general purpose register. In this register, what you have to do is you have to store the starting address of the string. It means DX will occupy this 100, this starting address, this number 100. It should occupy this number 100 there. Okay, so what we have to do is we have to copy the starting address of the string to the DX register. Okay, but we know how to copy something from, like we know how to copy a certain value to a register. But how do we know what is the starting address of this particular string? That's the question. If you if and how do we know what is the starting address of the string, and how actually this entire thing, like copying the starting address of the string to DX register, we can write with the help of an instruction, and that instruction is load effective address. What this load effective address instruction is doing is basically it is copying it is moving the starting address of the operand of the second operand here. So it means you see here load effective address to DX register of what? Of string 1. What this LEA is doing basically, it is copying the starting address of string 1 to DX register. Okay, it means it is copying 100 to DX. This LEA will compute the starting address automatically by itself, and then it will copy it to DX register. Okay, done. And why you are copying it in DX register? Because that's where we want the starting address of the string to be if we want to display it on the screen. Okay, done. Like we copied the starting address to DX register, and then what we have to do is Then most probably you guessed it. Yes, right, that's true. Then what we have to do is we have to move a certain number to AH register. Like say if we want to terminate the program, then what we did is we copied the certain number is 04C. We copied this number to AH register, and after that we immediately call int 21H instruction. I mean we like we call the particular service routine, interrupt service routine. Now here what is the particular number is, if we want to display something on the screen, that number is 09H. We'll be storing 09H to indicate that okay, the interrupt service routine for displaying a string on the screen should be called or should be executed. And how we can activate that particular code? Just by writing int 21H. Okay, and then as soon as this interrupt is called, immediately it will display you the content of the string whose starting address is at the X register. Okay, if we store 09H to AH register and then we call int 21H, then what it will do is it will go to DS register and it will go to the starting address of the string. It will actually see what is the content of DX register. So whatever it is, it will go to that particular memory location and it will start printing the characters from that location. Say for example, in this case, what will happen? As soon as we call AH, 09H, it will first go to DX. And what is there in DX? It is, according to this picture, there will be 100 in DX. So it will go to the 100 location, and then from there, it will start displaying the characters one by one on the screen. Okay, so okay, then you might be thinking, okay, that's good. But the thing is that when it is going to stop. See here, it will go to 100, it will print the character, then it will print the next byte, then it will print the next byte, next byte, next byte. So obviously at some point of time it has to stop. And where it is going to stop? Yes, if people guessed it right, this dollar symbol. As soon as it sees this dollar, special symbol dollar, it will know, okay, now this is the end of the string. So I have to stop printing. And that is the importance of this dollar symbol. And it is same actually, like if you know C, like you remember from C programming, like null symbol, printf percentage SS, say for example, how actually in C program the printf statement knows where it has to stop printing. It just sees if the current character is null or not. If it is null, it will stop printing there. The same way, this dollar symbol is important in 8086 program. Like it marks the end of a string. Okay, so what basically these three lines are doing is, first thing is, see here, first thing we need to understand that if 09H is there in AH, and then if we call in 21H, that is the interrupt service routine, the corresponding interrupt service routine, what it will do is, it will first go to DX register. It will assume that there the starting of a particular string is there in the X register. So for that reason, uh, before actually calling this interrupt service routine, what we have to make sure is that, okay, the starting address of the string is there in the DX register. And that's why we wrote it in this way, LEA DX, str1. It means load effective address of string 1 to DX register. Okay, so this program is going to now display whatever it is the string which is there at the address str1. Basically here we have written hello, so hello will be displayed on the screen. Let's first see this program in debug mode, and then we'll see it, like we will directly execute it and see the output. Okay, let's do it first. Our program is pp5. You have to save the program. My autosave is on, that's why I'm not saving it. So first compile the program, tasm pp5.asm, pressing enter. There is no error, no warning, good. And then we'll be writing tlink pp5 and then tdpp5. We'll be seeing actually how this LEA actually works. Okay, that's my main point here to run it in debug mode. Okay, done. Let me show you the program also at the same time. This is a program, right? Okay, first see, we will be seeing it from the beginning. We are copying move AX comma data segment. The base address of the data segment should be stored in AX register, should be copied to AX register. Now see here, right now the content of AX is 0000 and at the rate of data is automatically converted to 48AE. It means that is the starting address of the data segment. So that address or that particular number will be, it is a 16-bit number written in hexadecimal. So that 16-bit number will be copied to AX as soon as I press F7. So this is the current instruction which will be executed as soon as I press F7. I'll be pressing it at the count of 3. You people just have to keep your eyes here. You should be able to see, okay, now this AX from 0000, it will be changed to 48AE. Okay. 1, 2, 3. Here 48AE. And then what we're doing is we're copying the content of AX to DS register. It means here DS is right now 489D. It will be after the execution of that instruction, it will be 48AE. Just keep your eyes here. I'll be pressing F7 in a moment. 48AE. And then move DX, 0000. What was the actual instruction that we wrote there at that place? It is, see here, this was okay, and this is the second, and the third one lea dx comma str1, but here it is now dx comma 0000. See, the instruction itself is actually changed here. Lea is automatically converted to move instruction. Okay, basically, see what we have to do here. We have to move the starting address to dx register. But the thing is, we need to also compute the starting address, and for that reason, we wrote here these LEA instruction. So LEA first computes the starting address of string 1, and whatever that address is, then the next instruction, or whatever the address is actually, that address is actually fed as an input to the move instruction, like move dx comma that particular address, and that's what is reflected here in this program. Move dx comma 0000. It means that is the address from where this hello string is getting stored. Let's see whether it is the case or not. It is the case or not. Okay. So how do we do that? We will see what is the content of this data segment register. See here in data segment, you can see here 48 is there in byte number 0, and see the corresponding ASCII code is H. You might be thinking, is it so? Yes, see here, 48 is in hexadecimal. We know what is the, like, I guess you people know, like, what is the ASCII code for A? Okay, let me write it slightly down there. See, these characters are written in a capital letter, okay? Like this, HELLO. Now, we know the ASCII code for A is 65 in decimal. So, ASCII code for H will be 65 plus 8. 8 or 7, I'm confused. Anyhow, 65 for A, then we have B, C, D, E, F, G, and H. So 65 it is, then 66, 67, 68, 69, 70, 71, 72. H is 72 in decimal. Now, what is this decimal if we convert to hexadecimal? I'll be using an online site somewhere, and there I'll be just typing, say, hexadecimal to decimal. I'll be using this site regularly if we have to convert. Now, what we want to convert is not hexadecimal to decimal, actually. We want to convert what this 72 decimal to hexadecimal. So I'll be just choosing the other things. Like from decimal, we want to convert to hexadecimal, and the number is 72. If you convert, you can see it is enter the hex number. No. Decimal to hexadecimal. So we'll be writing here 72 decimal. We'll be converting it. The hexadecimal number is 48. And that's what we can see here. At byte number 0000, we have this hexadecimal equivalent of the ASCII code of this, uppercase H, which is 48. Similarly, E is 45, L is 4C, 4C. See here, these 4Cs are coming twice, and that way. And at the end, these dollar symbol is stored here. Now, see, after that also $D is there, but don't you worry. I mean, these are some garbage characters. I mean, obviously, at each and every byte, there will be some data. Here, all of them are 00s. But for some reason, this byte has the sequence of zeros and ones, which can be converted to the ASCII code of lowercase d. And here it is the sequence of zeros and ones, which can be converted back to the ASCII code of this symbol dollar. But our point of interest is this. From byte number 0, this hello string is getting stored in DS register, right? And that is, since it is stored from byte number 0, actually the starting address of the string will be 0. So that's what this LEA is doing. LEA ds, str1. First, it will compute the starting address of the string, and then that input will be that starting address will be given as an input to move instruction. Basically, what this move instruction is doing is it is copying the starting address of the string to the X register. That's what it is doing. And after that, now right now, this is the instruction which will be executed, moving 0000 to DX register. Right now, the content of DX is 0000 itself by default. And then if I press F7, there will not be any change basically. So let's press it, F7. Done. And the next instruction is move AH, 09. As we know, this is a okay, it will be copying 09 to AH register. So this 48 will change to 09, as you can see. And then interrupt 21. So it will call the interrupt service routine. And if 09 is there in the in AH, we know that it is going to display the string on the screen. I'm pressing F7. It has actually most probably displayed, but okay, no, that way it is. And then the next instruction is in 21. Sorry, the next instruction is moving 4C to AH, and then terminating the program because we are executing in 21H. Okay. So my point here was like to show you how these these AX like how we can copy the starting address to AX in debug mode. I showed you, and how in debug mode I showed you like how we can copy the starting address of the string to the X register. Now this starting address might not be always 0000. Don't you think it that way? It could be anything basically. Okay. Now let's execute the program and see whether it generates the output on the screen or not. That's our main goal, right? That was the thing that we were interested in at the beginning. Okay, let's see it. How we can do that? I'll be first quitting from this debug mode, and then directly I'll be executing the program just by writing the name of the program, pp5. And I'm pressing enter. You can see hello is being displayed on the screen. It means this is the first 8086 code in this video series we have written that actually generated an output in the output screen. And what is that output? Whatever it is, the string that we store here in str1. So we can write here, hello world, how are you? How are you doing? I mean, like this. So if I now, my autosave is on, but in your case, you have to actually save the program. And then let's now see, this time if I execute, don't expect that hello world, the entire string will come. It will only display you hello. The reason you most probably know, right? So what we have to do is, if we want to see the effect, since we changed the source code of the program, again you have to start from the beginning. That is, you have to first compile the program, then we have to link the program, and then we have to execute this program. And then this time we'll be now we can see that the new output of the program, the output of the new program that way. Anyhow, hello world, hello, how are you doing, or something. So this is how we actually display a string on the screen. So what we have to do is, whatever it is the string that we want to display on the screen, we have to store it in a variable. And then the address of that particular variable, that the address of the string, basically, that string we have to load to the X register. We have to store the address of the string to the X register. How do we do that? We can write load effective address of string 1 to the X register. And once it is done, then we can call this interrupt service routine with the AH value 09H. Okay, so done then. Now the next question is how we can display a certain character on the screen. Yeah, displaying a character is different than slightly. Yes, you might be saying, okay, that is also right. Like you can store, say for example, we want to display the character, say for example, the capital A. So certainly you can do this str2 db character A and then dollar. Yeah, you guessed it right. This is how I'm going to do it. And then suppose we want to display now string 2 on the screen. Then what we'll be doing is, first we'll be copying the effective address of string 2 to DX register, of string 2 to DX register. And then we will be calling the same, like we'll be storing 09 and H in AH register, and then we'll be calling interrupt 21H. So that way, certainly it will display you string 2, that is just a single character on the screen. Certainly that is one way of doing the thing, I guess. Yeah, hello world, and this A is displayed. But point is not in this way. Suppose directly can we display a character? That's our point. Before that, let me write here one thing. CD output. Oh, there is an error message. Extra character on line 5. Do I write comma? If it doesn't work, I'll leave. I'll continue. Okay. 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 Oh, this is what I was thinking of. If you want, like say, the first string is displayed wherever the cursor is initially, and then the rest of the strings will be displayed from where the first string ended. But sometimes we want the output in the new line. So you know the new line character in C programming. The same way, if you want to give the effect of a new line character in 8086 programming, then these 2 bytes, you have to start your string with these 2 bytes actually. Okay, your string will not start from say what it will do is here. If it is your string is say hello, but actually storing hello in this way, you'll be storing the first byte as 13 decimal, second byte as 10 decimal, and then the third byte onwards the actual string. So that way these two conjugatively, like combinedly, they will be treated as a new line character. Okay, it means the cursor will move to the beginning of the next line, and then rest of the things will happen. Okay, now our point was how we can display a single character on the screen. That is our next point, right? So what I'll do is, for that reason, I'll be writing it as a different program. I'm calling it pp6.asm. So here again, let me write the basic skeleton fatafat dot model. Sorry, I said quickly I'll do that, but again I'm doing mistakes. Anyhow, small dot data segment dot stack segment dot code segment, and move to AX register the starting address of the data segment, and move this to DX register, and then terminate the program just by moving uh, to AH register 0 for CH, and then int 21H, and then end. Done. And our point of interest is that we want to display a single character on the screen. That is our point of interest. Now see, if we want to display a single character on the screen, then what we have to do is, see, it is just a single character. It is not a string. If it is a string, see here, the content of a string cannot be stored in a single register. That you should understand, right? Because the string is actually, it's a collection of some characters. A register is only 16 bits maximum, right? So in 16 bits, you cannot store an arbitrarily long string. You can store a string which have maximum of 2 characters, but you cannot store more than that. So for that reason, what we did is, when we had to display a string on the screen, so what we did is we stored the actual string in the memory, and then we copied the starting address of the string, which is certainly a 16-bit number, to DX register. And from there we said, now okay, whatever it is from starting from DX till the dollar symbol, display everything on the screen just by writing by calling that proper interrupt service routine. Now here, if it is the case of displaying a single character on the screen, you see the character actually you can store in a 8-bit register itself. What we have to do is, we have to copy in the DX register, not exactly in DX, we have to copy, see, DX is nothing but it is DL and DH register together. So in DL register, we have to copy the character that we want to display. Say, for example, we want to display the character, say, for example, P. So we'll be storing the particular character there in DL register. You might be thinking how we can store a character in DL. Storing a character in DL register basically means storing this particular character has an ASCII code within the range of 0 to 255. Now see, this range of numbers can be represented by 8 bits. So whatever that 8 bits are, those 8 bits are for that, say for example, P means, just for the sake of example, I'm picking a number. Say for example, this P is actually say 95. So these 95, certainly you can represent it as a sequence of zeros and ones, 8-bit sequence of zeros and ones, and that particular sequence we have to store here in DL register. That's what we meant. That's what I meant by storing the character in DL register. Okay. Now we have to store the the character in the DL register, and after that, what we have to do is we have to call the proper interrupt service routine. And to do that thing, first thing that we have to do is we have to store in AH register. This is your AH and AL register. So here we have to store this number 02, the number 2. We have to store this number 2 there. The way we stored 9 to display the content of a particular string, here we have to store 2 in AH register. And after that, we have to call int21h. So that way, what it will do is, whatever it is the character there in DL register, it will display that particular character on the screen. It is simple, straightforward. The first thing is we have to store the character in DL register. Then we have to store 02 in AH register. And then we have to call int21. We have to execute int21h instruction. And that instruction will actually in turn will call a function that displays the content of the DL register, the ASCII code of the content of the DL register on the screen. Okay, let's write the code and check. So suppose we have loaded the content, DS is now pointing to the beginning of the data segment register. And then what we want to do is, say for example, we want to display the character P on the screen. So what we'll be doing is we'll be writing move to DL register the character P. This way you can write, and there's certainly other ways are also there. I'll be coming to that point in a moment. Then we are storing the character P in DL and then move to AH register the specific value to, same as hexadecimal decimal, and then we'll be calling int21h. Okay, and that will display the content on the screen. The content of DL register. I mean, that will go to DL register. It will check, okay, what value you have. It will convert it. It will convert it to its corresponding ASCII code, and that ASCII code will be displayed on the screen. Okay, let's execute this program and see the output. This time we'll be directly executing the program. We'll not get into this debug mode anymore. So tasm pp6.asm. This is my code. I mean, I'm compiling it, and then I'm linking it, and then I'm executing it. pp6. So what we expect as an output, the character capital letter P there. So capital P is coming on the screen. So whatever it is the content of DL, that will be displayed on the screen. So let me change this P to X now. Now, if I execute this program, you will be seeing X on the screen. Okay. First, I have to compile. Then I have to link. Okay. And then I have to execute. So as soon as I execute, we'll see an X on the screen. Okay. Now, if saw me here writing the character directly. Okay, but I said what this DL contains, it contains a 8-bit number. So basically I can write here any 8-bit number. You see, I can write here any 8-bit number, and that 8-bit number will be displayed as some character on the screen. So when I say any, just let me pick a random number. Say for example 327 in decimal. As I said, no, okay, it should be within the range of 0 to 255. So certainly I cannot choose 327. Let me choose 251. I don't know what exactly is the character, but it is a 8-bit number, certainly. And that is that I have stored in DL. And then I want to see what is the ASCII code of that particular number. So what we'll be doing is we'll be compiling the program once again, and then we'll be linking it, and then we'll be executing it. And see that most probably musical symbol is the ASCII code of the number 251. Okay, let me then write here one number whose ASCII code I know. That number is 65, and this is the ASCII code for capital A. Let me check whether it displays capital A on the screen or not. So here you see this and this, and I'm executing capital A. Now see, do not you think that it is going to display 65 on the screen? It is not going to display 65 on the screen. It is going to first, see here, this is what it will do. This is what it will be displaying on the screen. See here, in DL register, it will first go to the DL register. Certainly it is a sequence of zeros and ones in some way, 8-bit zeros and ones. So it will be first converted to a number, whatever that value is, whatever this value is. Okay. Now that value will be converted to its ASCII code. So if the value is say 65, it will be converted to its ASCII code, which is your ASCII character, sorry. It will be converted to ASCII character, or code in the sense, yeah, character only, ASCII character. So 65 ASCII character is say capital A, and that capital A will be displayed on the output screen. So do not expect 65 here. It will display this capital A, or whatever it is the character that particular number represents. Okay, so if it is the case, then you most probably can now know, like if I write here 65, then what is the output? It is showing you an A. So if I write 65, 66, then certainly it is B. So if I write, I guess 97, then it is the lowercase a. So let me check. So compile, link, and run. So lowercase a. So that way you can display a specific character on the screen. You can directly store the character on the I mean in DL, like writing it within double quotation, or what you can do is you can write the the ASCII code of the character, and then you can use move instruction to store that particular value in DL register. And then in AH register you have to store the specific number 02, and after that you have to call this interrupt service routine. Now when you call interrupt service routine by executing int21h, it will first check what is there in AH register. And if it finds 02 is there in AH register, so immediately what it will do is it will go to DL register, it will get the content, it will convert it to an ASCII code, and then that particular ASCII code will be displayed on the screen. So that is how we can actually display a string on the screen, as well as we can display a single character on the screen. Hope you people have understood more or less the things that I tried to explain here. If you have any doubts or queries or anything, you people can ask me in the comment section. In the coming videos, we'll see how we can make use of these concepts to do some slightly more meaningful tasks. So, for example, one task that we would like to do is, see here, right now we know how to display a single character, or what we know is how to display a single string on the screen. Just for just assume, suppose now we have to display the number 97 on the screen. Here we do not want to display the ASCII code, the equivalent ASCII code of 97. We want to display 97 itself on the screen. How we can do that? Yeah, certainly one way is that, okay, 97 we can store as a string and then we can display it. Certainly that is one way. But suppose 97 is not coming, like we are not storing 97 anywhere as a string. Say 97 is the value of a particular register, and then we want to display that 97 on the screen. Then how we are going to do it? So these sort of things we will be addressing in the coming videos. So stay tuned. See you guys then in the next part. Till then, have a nice day.